All right, you should be in your notebook on the page that says Investigating Refraction, and I would like for you to read through it, but basically they got two lenses, and this is going to be kind of hard to see in this video, so if you get a chance, I would either look up convex lenses or come try them out with me and I'll show you, because it is really hard to show you on this video. But basically with convex lenses, you're going to get two of them, one thin, one thick, and you're going to put them on a page in a book. You can just use your notebook if you want, and you lay it down, and then you start bringing the ruler up and you start making observations. That's what they did in this chart. And then they held it away from their body to make the observations at the bottom. So let me show you what they did. So there's two lenses. Okay, you can see them in my hand. The bottom one is the thick one and the top one's the thin one. Okay, you can kind of tell already, even though this top one is bigger than this one, the thin one is actually bigger than this one, but the thick one obviously has this one's a little thicker. You can kind of tell already. So we're going to start with the thick one. And what they did, but I'm going to not be able to do this, they actually put a ruler down on their paper at the 0 marks. Let me flip this over. At the 0 mark on centimeters or millimeters. And then about they would start lifting up the lens, and they would start recording their observations about every 5 centimeters. But for me to show this to you, I'm going to have to do it without the ruler. So here we go. See if I can get this going. So first, they would have it down here, and you can kind of already tell, hopefully, that it magnifies it just a little bit. And then about every few centimeters, they would start making observations. You can see it's getting bigger, bigger, bigger. And the camera is probably going to be distorting this, but eventually it should go. You can see it getting blurry. So then they would say, oh, it's getting blurry, and it's upside down. I don't know if you can tell, but it's blurry and upside down. Then they would hold it away and look around the room. And again, I don't know if the lens is going to be able to do this or not. You can see wall is upside down, and it's actually smaller now. Okay? So it actually worked. But here is what they got, just to show you. About 50 millimeters away from the eye, you can kind of see the objects getting inverted. Okay? Then they turn the page and answer the question on 7. So if you need to pause the video, you can do that. Answer all those. And then this is what they got for 7, A, B, C, and D. Basically what I told you. It magnifies, especially towards the center of the lens, and when it gets too far away, it gets distorted and more curved, and then all of a sudden, whoops, the orientation means position on C, and that flips. So there you go. Then they did the same thing with the thin lens. So if you look at number 8, they're going to do the same process with the thin lens, and they did 8, 9, and 10, all with the same process. So I'm going to show you that. Okay, so again, I'm going to put down the ruler just so I can be able to show this to you. I'm going to take the thin lens this time, so the one that was the bigger one, but it's actually thinner. And if you lay it down, it really doesn't magnify much. In fact, some kids said it's not magnifying at all. And then you start lifting it up, and you can see not much, but it actually does magnify it a little bit, but not much. But oh, wait a minute. Now it's getting smaller, 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 and it's getting less and less. So, something's weird with this one. It does get bigger, but to a point. And then here I'm going to show you, see if I can get it with the word wall. Now, holding it away with the word wall. Again, I think the lens on this camera is going to mess up stuff. But eventually, if you look at it, and it gets really distorted. But you can kind of see the A is really big. Yeah, but I think the lenses, again, on the camera kind of messed stuff up. So I'll just kind of show you what they came up with. So 8, you would see upright magnified images with the lens 90 millimeters from page. As they move the lens away from the page, the image becomes inverted. See, we didn't actually even see that with the camera. It actually becomes the same size beyond the distance will observe a reduced inverted image. So with the camera, it really doesn't do that. So in the class, you may want to come in and try to see that or look it up on YouTube if you get a chance. So then on 9, they should distance objects are inverted when it's 90 millimeters away. The students described smaller observations with the thick lens, but at greater distance. So it took longer for it to magnify, and it wasn't magnifying as much. Okay. Then number 11, you can see at the bottom there, it's kind of like summing it up. Our conclusion was number 11. So pause the video and see if you can come up with a conclusion for this. Okay, I'm going to assume you came up with the conclusion. And you should have reached the point that really the thickness and the curvature of the lens and the image lens differ because of the degree of refraction. If you've got a thick lens like this one, it's more solid. There's more of a solid to go through. So the light rays are going to refract more, which is making this more magnified image than the thin lens. So basically making it's more of a solid. The thickness and the curvature lens slows down the light rays even more, makes that degree of refraction through the lens more when it's on a thick lens.